Welcome to the 23rd section of the course of Expert System with C++ and Qt. My name is Carlos, and now we're going to start the implementation of the inference kernel engine. Because inference kernel needs the workspace to work, and because the workspace is easier than the inference kernel, we're going to begin implementing the workspace. So, to begin with, let's create another library. It will have the name of inference engine. New project. You must select the C++ library, and then we will call it inference engine v2. I have one already. Next. Hold on. Let's just ensure that the type is shared library. Next, I think that we will need the Qt core. Let's just let it out. And the class name. Well, something that I might say is that, as you can remember, in Qt you can move from different types of projects using the .pro file. Well, for now, let's make just a library. Okay. So then, what you call inference kernel, because we just need the class, and that's it. Okay. So we can actually start creating the workspace class. So I go to the add new C++ class, that's correct, and the class name will be Workspace. There is no base class, and it didn't include anything, so next. Okay, we're good. I'm just going to advance a little bit and eliminate this constructor, and let's start the implementation. First, let's have a rule type enum in the header of the workspace. It will be public, of course, and it's an enum rule type. Modus ponens and modus tollens, and the last one is no type. Nice. Don't forget semicolon. Next, let's include the header that we're going to use. Well, in this part is a little tricky because we need to do some stuff. Okay. So we will get some definition from the prop compiler. So we'll link our project to this library. To accomplish that, we need to change the prop compiler to be a library. So go to the .pro and change this. Of course. So we actually need, it's already done. We just need to ensure that the template is equal to lib config. There's no config. Okay, config plus equal to static lib. I think that it's okay. And config, let's add C++11 just in case. C++11 config must equal Qt config plus Qt. Okay, and this part is also important. Next step, set as principal project and build. Just check. Procompiler v2. Okay, just follow me in this part. At the system file and search for the pro compiler. To add the pro compiler library to our project, we need to run in release. It's better to make it in release. Let me just show you. In this part, where is the book? I think it's here. You can change between debug and release. So you should go to the pro compiler v2 project in this way. Set as a active project. Search and ensure that it's the name of the pro compiler v2. Then click and release, and you will see that it started to release. And we just need to build it. So build. We need to wait in this part. Okie dokie. Oh, there are some errors. There are some warnings. Great. Okay, it seems that it works. So the next step is to add existing file and search for the prod compiler v2. I can search it easier in this way. It's in the book. Nice. This is not. There's another project. Don't mind about it. Here is. We need to take. Ooh, hold on. It won't be that easy. Because the prod compiler v2 is defined as an executable. So let's comment this. No, it's not. Template is equal to app, and the output is executable, so that's incorrect. I forget the shortcut. So template leave config add C++11, and this part is also important. I think that's everything that we need to do. So again, build and wait again. But I think that we need to review it to ensure that everything is correct. It's taking longer than I was thinking. Great. So now set inference as a active project at existing file. Go again to Qt 17, and this is the file that we need, libprof compiler v2, and its difference is that we need to differentiate it in that way. So go to open, and the next step is to build the inference engine v2. Assume that it's okay, and let's test it out. Include prop. He's not here, so we need to do another step, that is we need also to add two files to the .prod to do a reference to the prod compiler library. So I think this in this part we need to do a little of code include path. Oops. Plus equal. Let's search here. Sexy chick. I think that is in Qt 17. Search for. I think that there is a easier way. Go to Sorry, just find this directory, copy this shit. Sorry for the bad word. Okay, with quotes. Another line, please, and this one is lips with quotes also. But now we'll search for the .a file and copy this path. Oh my god. Polyreturn. Here it is. Oops. No, hold on. Lips. Nope. Rename. Copy it. Don't forget the .a, and we need quotes. Here we have. Let's build again. Go to Workspace and try it again. Include prop tributor. We need the prop tributor. Great. Okay, now that we can go to the Workspace and include everything else. So first, let's include the prop tributor and the type of containers that we will use. We're going to use the QMap, QVector, and QMultimap. QMap. If you have some doubts about what is the difference between them, I would suggest to go to a course of STL or go to the documentation of Qt. It's not difficult. It's really not difficult, and it's pretty interesting because the containers may identify a whole system. There is in artificial intelligence there is a difference between searching, and the only difference between two types of searching that they behave completely different are the one use the quote and another use stack. So pretty important. And next, let's define a private member. Guess what? It's prop tributor pointer, and it's PTB Hungarian notation. And some people say that it's ugly, the Hungarian notation, but I'm using it, and for now I don't care. So before continue, I would like to stop a little bit while explain Workspace in more detail. So Workspace is the right hand of the inference kernel. In the Workspace, there are all the tools and resources used by the inference kernel. Actually, the majority of tools are containers. So those containers will help the inference kernel to do its job and get more optimizations. Okay, so the containers that we are going to use are I'm going to define them in public. The first one is antecedents. So this container will be useful to hold every atom position in the tree and link this position to the given value. Remember that an atom might not have any value. Antecedents will be a multi-map. int. It's a pair, the index and the value. We can define integer to be undefined. And the reason that it's a multi-map is because we can have we can have duplicate or repetitive IDs, and the ID is the index of the tree, so we may refer several times to atom A, atom B in the tree, in the antecedents. So that's the reason that we were using the Q multi-map. The next one, the consequence, that is pretty similar to the antecedent, pretty similar. Underscore consequence. Right. The next one is rules. So for a few reasons we need to have a temporary copy of the knowledge base. We're going to see why this is important in the following videos, so keep going. And the rules will be a vector of indexes in the tree, and the rules. Next one, it's conclusion. And if you remember the last video, conclusion is the output of the expert system, so we need to have track of them. Q vector int underscore conclusions. Nice. Next one is denied atoms. This container contains atoms, and there are some atoms that we don't have to ask for them. They are not useful for the user. If this is not making sense, this will be explained in following videos when we talk about backward chaining. So just hold on. And this is also integral. I think that all the containers are referencing to the same thing, that is index in the tree, because the only thing that we are using is the tree. Okay. We denied atoms. Next one, relevant atoms are the input that is interesting in the inference process. This makes a difference among atoms to focus only in what we need. This causes, obviously, optimizations. The reason that is a Q map, guess what? Guess why? Relevant atoms. The reason that is a Q map, in spite of the Q multi-map, is because we don't want to have repetitive indexes. This will be very bad for our efficiency or process in the expert system. And because we only want to know which one is relevant and which one is not. We don't care about if it's persistent, it has a lot of occurrences in the tree. We don't care about that. We just want to know if which index, which value, and that's it. Next one is antecedents values. We can hold the value of a whole group of antecedents to make it easier to analyze them. In this way, we just need to ask if it's resolved already. In this way, avoid to process again its value. Remember that the atom's value cannot change. I don't know if I mentioned that already. When the atom value changes, it will make our expert system lie. It's like a doctor say, well, you have cancer, and after 5 minutes he say, okay, I'm sorry, you don't have cancer, it was just a joke, a bad joke. So the next ones, let's define it. Q map, and it's a int bool. I don't want to have a white space there. And antecedents antecedents value. So the consequence values, there is another container, and it's pretty much the same that the antecedent values, but with consequence. QMap. So you might ask, while we are having antecedents and antecedent values, good question. You will see it in future videos if I didn't explain it pretty clear. But the difference is that these guys might have undefined value, but these guys will need to be 1 or 0. And they have different uses between antecedents value and antecedents. The use of antecedents is pretty much have a track of all the antecedents, and in this one we are going to have the track of the antecedents value that really have the antecedents that have a value actually. So just to summarize, this couldn't have no value, and this will need to have value to be in that container. The next is inference rule, and this is optimization. In previous videos we can see that there are rules whose atoms have value already, so there is no need to change them again. So we can put them in the container and skip them. Do you remember that we have a list of 5 rules, and some of them has value already, and we don't need to care about them anymore? So this is for optimization, of course, and it's Q vector. There is a question, which one is better? What's the difference between Q vector or Q leaks, or a vector and a leaks in STO? I will put the question in YouTube. I just realized that I can do that, and it's pretty much amazing. Infrared rules. Q vector. The next one is rule type. Do you remember them? We haven't put it in here. And rule type. Here is. Sorry. Something very important I'm remembering right now is that, as you can see, we just having a code for production. I mean, we are not testing about the parameters in each the parameters values in each function that we have developed. And this is with the reason to make it the much faster the video. I really recommend you to do some code to validate the process and to catch bugs easier. Next, inference rules. The next one is ask rules. These guys are kind of a list of runtime exceptions. We determine which rule we ask already. This differs from the inferred rule by the reason that we haven't known the value of that rule. We just ask if the user to the user the rule that the rule can be undetermined yet. So Q vector, and it's also an int. I'm going to put it. Is it as atoms? And let me just put little bigger. And now finally the conclusion by value container. This is a principal container that we will pass to the user interface when we reach the results. It will say to the client, hey, here's your illness, you have cancer. I'm pretty sure about it. QMap int bool emp m conclusion values. Okay, so we've finished with the containers. Following the container, we will define the constructor passing the tree with the parameter as a tree and some useful functions. So in the public, it's just gonna rip this guy and define it. Prop tree builder ptb. This won't be, it should be const. Let me remember, it's a homework for me because I can't remember right now. Reset. These guys aren't const because we changed the members of the class. Void reset rules. Void reset antecedents and consequence. Antecedents and consequence. They're pretty straightforward. And void pick atom will have the entry of the tree, the rule, and if it's consequent, just to differentiate it to the antecedents. And that's it. Next one, it's reset denied atoms. Void reset the denied atoms and semicolon. Void reset conclusions. Yes, it is the point. What's point? And the destructor, why not? Workspace, and that's it. Okay, now you know these functions are straightforward. So this is the end of the video. In the next one we will continue our implementation of the workspace. Share this video in any social media that you have, comment in this video, and check our website geartex.com.mx. Thanks.